We're going to start Chapter 4, and Chapter 4 is all about regression analysis is the name of the topic, and we're looking at mostly regression lines, and regression lines gives us a way to compare two numerical variables. So 4.1, we're starting with a topic called scatter plots, and so the name of this section is Visualizing Variability with Scatter Plots. We're going to use StatCrunch to create scatter plots, so we're not going to have to worry about doing that by hand, and we'll see some examples of that later on. But what do we mean by a scatter plot? So a scatter plot is the primary tool for examining relationships between two numerical, try to sneak this in here, numerical variables. So that's the key thing, is we're looking at only numerical data. We want to look at the relationship between two numerical variables and see if one impacts the other in any way. Each scatter plot, or each point rather, in the scatter plot represents one observation. So if we take all our data and we put it on a graph, each individual point represents one observation. So let's take a look at this example. What does the scatter plot below tell you about the relationship between the number of floors in buildings, so that would be the variable here, and the heights in meters, and so that would be the variable here. And it's just like it would have been in algebra. You've got a horizontal axis, in this case those are the number of floors in the building, and you've got a vertical axis, in this case that would be the height of the buildings. And so each individual dot on this graph will represent a particular building, where it is in terms of the floors and what its height is. So what could we say? Well, hopefully you notice that as the number of floors goes up this way, so as we read the graph from left to right, so too does the number of floors. And it's not a perfect relationship, so there's always some exceptions to it, but in general you're looking for a trend. And so what could we say about this relationship? Well, we could say that the height of the building, so whatever the height of the building is, so the height of the building is associated, and that's a term we're going to use a lot, associated with the number of floors for the building. So there's an association or a relationship there between the number of floors and the corresponding height of the building. So when we look at a scatter plot, there's three things we want to consider, three things we would use to describe that scatter plot. One is the trend. So from left to right, as we look at the data or look at the graph, what is the graph doing? Is it going up? Is it going down? Is it not doing anything? Is it staying flat? And then the strength. So how strong is that relationship? If the points are close together, that indicates a stronger relationship. If they're spread apart, that indicates a weaker relationship. And the shape of the graph. So we're only going to look at scatter plots that are linear in shape, but they can be others. You can have ones that are shaped like a parabola, ones that are shaped like a logarithmic function, and so forth. But in this class, we're going to focus on linear scatter plots. So let's start with trend and what we mean by that. So you can think of trend as the general tendency, of the scatter plot as you read from left to right, and that will never change. We're always going to read it from left to right, just like you would read a horizontal axis in algebra. We always go from left to right. So the typical trends are increasing. So if the graph is increasing, we also can say that it has a positive association. If the trend is decreasing, then we would say that the scatter plot has a negative association. And it could be that there is no trend. So the graph is just kind of, the points are all over the place. There's no clear trend. We would say that it's not positive or negative. All right, so the next example, we have a scatter plot of the weights of 36 cars versus their horsepower. And sorry, this ended up on the next page, so you're going to need to turn the page with me. So here's the graph. So we've got the weight along the independent axis and the horsepower along the dependent axis. How would we describe this trend? So as you consider the weight going up from left to right, vertically, what is the data doing? And so hopefully you see as the weight goes up, these horsepower values tend to go up. Now there might be some exceptions to that, but in general, the trend is upward. So we would say that this scatter plot shows a positive trend because the graph increases as we go from left to right. This means that as the weight of the car increases, the horsepower also tends to increase. And so we're always going to describe these in terms of the independent variable. And I've used that term. The independent would be like your x value, this way, your horizontal value. The independent variable, we're always going to describe these as in terms of the independent variable increasing. So as the independent variable increases, what does the dependent, that would be your vertical distance, what does that do? Does it increase or decrease? Let's take a look at another example. So we have the scatter plot of the weight of 36 cars versus their mileage. So we're looking at the weights as the independent variable and the mileage as the dependent variable. And so mileage is also thought of as MPG, or miles per gallon. So what is the trend this time? As we look at the graph from left to right, so as the weight increases, what is the trend generally in the miles per gallon? And hopefully you see that it's going down. And so we would say that the scatter plot in this case shows a negative trend because the graph decreases from left to right. This means that as the weight of the car increases, remember we always describe the independent variable as increasing, so in this case that's the weight. As the weight of the car increases, the mileage tends to decrease, and that's what we mean by a negative trend. Okay, the next example, it says below is the scatter plot of heart rate, or beats per minute, versus the body temperature in Fahrenheit. So our heart rate is the independent variable and the body temperature is the dependent variable. So take a look at this graph. As the heart rate goes up, is there any clear trend? Does the body temperature look like it's increasing or decreasing, or does it not look like there's any real trend? Hopefully you see that the points are pretty scattered all over the place, and there's not a trend going upward like there was in this example, or downward like there was in this example. And so for that reason, we would say that this scatter plot shows no trend, because the points seem to follow no predictable pattern. So this means that there is no relationship between heart rate, sorry I didn't leave you much room here, heart rate and body temperature. Doesn't seem to be a relationship in this data. Take a look at the next example. It says consider the scatter plot shown below. So on the next page we have a graph here, and it says the data set shows an association between the variables x and y, but it cannot be characterized as positive or negative. I'm just giving you this as a quick example to see that not all scatter plots are going to be linear in trend or in a shape. So we've got, this almost looks like a parabola. The points start to decrease and then they kind of increase. And so for this one, we can say that this is not linear. And for this class, since we're just an intro class, we're going to keep it simple. Everything we're going to look at is going to be a linear trend. But I want you to know that it doesn't have to be linear in the real world. And if you go into Stats 2, you'll see that some situations where they're not linear. So now let's talk about the strength. So we mentioned the trend. Let's talk about the strength. So for the strength of an association, how would we tell how strong that is? So a scatter plot with a large amount of scatter or vertical variation indicates a weak association. And we'll look at some examples here. So if the scatter plot, if the points are really spread out vertically, that's an indication of a weak association. A scatter plot with small amounts of scatter or little vertical variation indicates a strong association. And when we get to the next section, we're going to have a number we're going to use to actually evaluate this. But for now, we're just kind of eyeball it and visually compare which one we think is stronger versus another graph. So here's an example of that. Below are two scatter plots. One looks at the height in inches. So the first graph here looks at the height in inches versus the weight of somebody in pounds. So we've got a bunch of people. We've measured their height and their weight, and we're putting it on a scatter plot. So the height is the independent variable. The weight is the dependent variable. On the other graph, we have And this could be the same participants or not. I'm not really sure. They didn't tell us that much, but it could be the same participants. But on the other graph, we're comparing the waist, so the waist measurement in inches versus the weight in pounds. And so what I want you to do is kind of look at the two graphs and think about which one looks like it has a stronger association. The one that has less vertical variation, so looking at the points this way, less spread up and down, that one is going to be the stronger of the two associations. And so hopefully you see that this graph over here, the points are a little bit tighter, a little bit less spread out vertically versus this graph over here. So there seems to be a strong association between, I should say a stronger association between waist measurement and weight in the second graph. So let's say between your waist measurement and your weight. So in other words, there's less vertical variation in the second graph. So if you want to make a note, less variation here versus more variation here. So there's less vertical variation in the graph than between the height and the weight. So if I were to look at these on the surface, I would say that my waist size plays a bigger role in what someone's weight is going to be rather than just looking at their height. So let's talk about shape. That's the last thing. And shape is real basic. Either the graphs for us, the scatter plots, are going to be clustered around a line, which means we're working with a linear trend. Not all data trends are linear, like we saw that one earlier, and we would model these using some kind of a curve rather than a line. However, we're going to stick to linear for our purposes. Let's look at the next example. It says the scatter plot below shows that there is a blank between snout vent length of alligators and their weight. Sorry, this is on the next page. Let's take a look at it and we'll come back. So here's what we're looking at. So the snout vent length is the independent variable, and the weight is the dependent variable. We're looking at alligators, it looks like. So how would you describe the shape of this? If we can think about if we could draw a line that models it and the data is relatively close to that line, then we can say this is a linear trend. In science class, you may have heard the term best fit line. That's the same idea. It's the same type of thing that we're doing. So if we can model it using some kind of a line, then we say it's a linear trend. Let me go back so we can fill in this blank. The scatter plot below shows that there is a linear, I said trend, I'm going to say association, although those terms are used interchangeably. You could say relationship. That would be another term you could use. Association, relationship, trend, those are all used interchangeably. So there's a linear association between snout vent length and weight for these alligators. In the next example, the scatter plot below shows that there is, so they didn't tell us what these variables represent. I got this picture from somewhere online, and they may have said what X and Y were somewhere else. But for right now, we'll just go with X and Y. The scatter plot below shows that there is not a linear association. So we'll say there is a non-linear association between X and Y, whatever these variables are, because you'll see that this time we're best modeling using some kind of a curve rather than a line. Like I said, we're going to stick to linear for everything. All right, so when we're writing descriptions, what are we looking for? So let's go back to those three things we're always going to use to describe a scatter plot. We're going to talk about the trend, whether it's positive, negative, or there might not be a trend. The strength, and we'll get more into how strong a relationship is using a certain number in the next section. And then the shape, we'll mention that it's linear or nonlinear if that happens to be the case, but then we wouldn't discuss the other two if it's not linear. And also mention any observations that don't fit the general trend. We've talked about outliers before, and these can have outliers as well. If I have a point somewhere on the graph that's far away from the rest of the points, say my alligator data back here in this picture, let's say I had a point way out here, that would be considered an outlier because it doesn't fit the rest of the data. It doesn't follow the trend with the rest of the data. And so if that happens, you'll want to mention those as well. Be careful describing associations. Always use the phrase such as tends to. There's always, let me write that out, tends to. So there's always some points that might not exactly fit the trend, not necessarily outliers, but points that just don't fit the trend. So when you're describing an association, you always want to be really careful with your language. As X gets larger, the Y tends to increase. Those are the kind of terms you want to use. Always point out any data points that appear to be unusual or not part of the pattern with the rest of the data, like those outliers we just talked about.